Don't forget to subscribe and ring that bell.
Hello there. How we doing? Me? I'm fine because we are going to do some calculus. Free response question number 5. Cinco en español, cinque en italiano. But we were going to do this from the 2022 practice set of free response questions. And, we don't get a calculator, but who cares? We got this. We are good. We have this. Let's start. Number 5 reads, consider the differential equation dy dx equals 1/2 sine of pi over 2x times the square root of y plus 7. Right? Let f of x be the particular solution to the differential equation with the initial condition f of 1 equals 2. The function f is defined for all real numbers. And 5a asks, a portion of the slope field for the differential equation is given below. Sketch the solution curve through points 1, 2. All right, so here we go. I'm going to come down here a little bit, and then I'm going to, let's pick another color. Let's go something that stands out. Orange, maybe? Yeah. The point 1, 2 is right here. Okay, they gave us that. I hope and pray that all your questions are this easy. All I'm going to do is I'm going to start a line going to the right and to the left, but I'm going to follow those little shorter slope field dashes. Meaning I'm going to go up, over, flat, down, and they shouldn't be corners. I mean, you should make them curve. I'm just exaggerating it so you see how easy it is. And I'm just going to follow it down and out. There you go. Now let's do the same thing to the left. Okay, it's going to kind of come down, flatten out, come up, flatten out, come back down, and there you go. That's it. That is literally it for 5A. Love questions like that. Love them. 5B tells us, write an equation for the line tangent to the solution curve in part A at the point 1, 2. Use the equation to approximate f of 0.8. All right, if you don't know, now you know, because anytime they ask you to write an equation of the tangent or the tangent line or a line tangent, you should automatically be going to y minus y1 equals m times x minus x1. And we really only need 3 pieces of information here. I need a coordinate for my x1 and y1, which, by the way, they give us right here. All right. And then I'm going to need slope. Slope is the same thing as, you guessed it, derivative. It's the derivative. Anytime we're doing a problem where we have to come up with an equation of a line, this is calculus. The bulk of the work will be the derivative. Okay, and here it's really not that bad. All right, so let's take 1 for x1 and 2 for y1. Let's put those in right now. So y minus 2 equals, I don't know the slope yet, all right, times x minus my x1 value, which is 1. Okay, slope is the same thing as the derivative, in which case we have, I'm looking above here, and this is good. Notice I have an x and a y that I need to input. This x and this y are going to go into the derivative. So I've got 1/2 sine of pi over 2 times my x value, which is 1, times the square root of y, which is 2, plus 7. All right, and if you know your basic trigonometric, and especially in this case, sine values, this is real easy. Okay, you should know this. All right, so 1/2 sine pi over 1, or excuse me, pi over 2 times 1, still pi over 2, plus, yeah, I'll be okay, times the square root. You should also know 2 plus 7 is 9. And you should also know the square root of 9 is 3. You see these problems without calculators? It's the setup. It's not the algebra. It really isn't. Okay? A lot of people freak out when they don't get that calculator. It's like their little blankie. It's gone. But you know what? The math is really simple. So I have 1/2. The sine of 90, or the sine of pi over 2, is 1. times the square root of 9, which is 3. If I multiply all those together, I get 3/2, and that's my slope. So let's go to the left side of the screen and put that 3/2 right there. All right, so this is my equation of the line. Right? Now I need to use that. Okay, I need to use that to figure out or estimate what f of 0.8 is. Keep in mind, when they ask us for f of 0.8, they're really saying when x is 0.8, what's my y value? So the first thing I'm going to do here on my equation is I'm going to add 2 to both sides just to get y alone, because that's what I'm solving for. All right? Y equals 3/2 x minus 1 plus 2. All right, now let's throw in our x value of 0.8. So we got 3/2 times 0.8 minus 1 plus 2. Well, if I do this math here, 3/2 times a negative 0.2 plus 2, and we are almost done. Thank goodness. 2 goes into this, negative 0.1, and if I multiply these, you get negative 0.3 plus 2, and you get 1.7. That is what your f of 0.8 is. So that really was not difficult at all either, the equation of the line. And then the simple math to plug in an x, an input, and get an output from that equation of the line. Right? So far, so good. 5 is nice. 5C. This one is really more, this is going to be more in explaining how we get the answer than actually getting the answer. 5A was easy, B was easy, and so was C. D has got to be separable differential equations. It's got to be. Anyways, let's focus on 5C. It is known that the second derivative of f is greater than 0 for the values of x between -1 and 1 inclusive. Is the approximation found in part B an overestimate or an underestimate for f of 0.8? Give your reason for the answer. All right, so let me explain the answer, and then we'll write it down, and hopefully it will make sense after you've seen the explanation. So it's good to understand the reasons for our answer as we write it, so you can kind of connect that. All right, so basically, well, let's do this. F of 0.8, okay, we had, for part 5B, if you were with us for that one, we really just found the equation of a line tangent, and then we figured out what f of 0.8 was. We estimated what it would be based on that line tangent, all right? So f of 0.8 is actually in our interval here, okay? And what do we know about our interval? That the second derivative is always positive. It's always greater than 0. So this is what we're going to do here. If I have a graph, and this is part of the explanation, and between -1 and +1, okay, I am always smiley face or concave up. All right, that's what this is telling me. All right, we in the previous one used an equation of a line tangent at 1. Let's call this 2. All right. For 5B, we found the equation of a line tangent right here. All right, that's what all this work was. Okay, here was the equation of the line, and then we figured out that the estimation of f of 0.8 was 1.7. All right, well, first of all, if 1.7 is right here, and the actual point, the value is right here, that is below. Okay, that is below the actual curve of f, so it's going to be an underestimate because it's lower on the y-axis. Okay, it's lower on the y-axis. All right, so that's one thing we could say, but why is it lower? Give your reason. It's lower because we have a smiley face. If I have a curve that's going up, and I draw a line tangent to it anywhere, any one of these points in the line are actually going to be less than any of the points, corresponding points in the green line. It's going to be lower on the y-axis, okay? And that's why we're going to say it's an underestimate. Okay, it's an underestimate. We got to give a reason, right? So we're going to say, since, okay, f double prime of x is concave up, I guess we could say in the interval from -1 to x to +1, our approximation is an underestimate, which means our estimate of 1.7 will actually be lower. Okay, so again, let's look at this graph part. Let's look at this graph again right here. Okay, here is 0.8. When we use our red line, the line tangent, okay, we get 1.7. Okay, but if we go to the green line, and I'll do this in that nice orange again, 1.8 is like right here. Okay, it's actually higher up. So my 1.7 is lower. Okay, and that's why it's an underestimate. Well, how come it's like that? Because our line tangent is touching something that's concave up, where the second derivative is positive, just like we have in this little drawing right here. Yeah. So you see why the explanation, I mean, I drilled it home a few times, and I might be overdoing it, but it's critical to know that. That's part of the reason. It's concave up where we have our line tangent. So we will be below that. In fact, the word below might be appropriate to put in our reason. There's an awesome underestimate here, so we can say, since the line tangent is below f of x. All right. I mean, maybe that's overkill, but I mean, it is what it is. 5D, and here it is, our separable differential equations. Use separation of variables to find y equals f of x. The particular solution to the differential equation, dy dx equals 1/2 sine of pi over 2x times the square root of y plus 7, with the initial condition, f of 1 equals 2. Now remember, this is really a coordinate. When x is 1, y is 2. So our equation needs to satisfy this. All right? So the first thing I'm going to do is I need to get, I'll rewrite this. I need to get my y's and dy's on one side and my x's and dx's on another. So I will rewrite this for the sake of space. 1/2 sine of pi over 2x times the square root of y plus 7. All right, first of all, let's multiply both sides by 1 over the square root of y plus 7 times 1 over the square root of y plus 7. Right? These go bye-bye. Now I multiply the left side by dx, so these go by, and the right side by dx. All right? So let's rewrite what we got, nice and clean. We have, I am going to take this. Okay, I'm going to take the denominator, bring it up, and make it a fractional exponent. Technically, this is 1 over y plus 7 to the 1/2. But I'm going to bring it up and make my exponent negative. It's always easier to integrate when I have exponents, okay? So I've got y plus 7 to the negative 1/2, okay, dy equals 1/2 sine of pi over 2x dx. Here we go. We've got both of these set up. Now it is time to integrate both sides. Okay. So let's integrate both sides. All right, the one on the left here, I'm going to add 1 to the exponent, y plus 7 to the positive 1/2, and then multiply Well, divide by a half, okay? So I'm going to have to divide this by a half, but when I divide by a half, it's like multiplying by the reciprocal. So it's like multiplying times 2, okay? Plus a constant. There are no bounds. I will call that constant 1. Ooh, the right side here. I think I'll do a little bit of u sub. If u equals pi over 2x, okay? So I'm really going to integrate the sine of u. All right? Du is going to equal pi over 2 dx. All right? Well, I only have a dx. This 1/2 we're going to put in the outside. It's going to be 1/2 the integration. Okay, this is already gone. The only thing left to sub out is the dx. So I got to get the dx alone. So I'm going to multiply both sides here by 2 over pi. By 2 over pi. So in for my dx is pi over 2, or excuse me, 2 over pi, which again, I'll put that on the outside. Okay, du. Okay. Now it's becoming a little bit easier, okay? What do I integrate? Okay, or I integrate sine, meaning what do I take the derivative of that would give me sine? Well, cosine would give me negative sine, but I have a positive sign, so I got to negate that. Plus the C2, all right? Oh, these 2's cancel on the outside, so I've got 1 over pi. Okay, and the only thing left is to bring my u back in. Okay, what was u? U was pi over 2 times x. So let's bring that back in. We've got 2y plus 7 to the 1/2 plus a constant 1, we'll call that, equals 1 over pi times the negative cosine of pi over 2 times x plus constant 2. All right, here we go. Now, let's get the constant over to one side. If I subtract constant 1, this goes bye-bye. I subtract constant 1 here. Boom. I've got 2y plus 7 to the 1/2 equals 1 over pi negative cosine, well, times, it's a dot there, negative cosine of pi over 2 x. Okay, a constant minus a constant is still a constant. All right, I need to find that c. Okay, they want me to come up with an equation. I cannot come up with an equation with that c in there. So how do I do that? I take the initial condition they gave me. This initial condition right here. When x is 1, y is 2. So I'm going to come back down here at x equaling 1 and y equaling 2. All right, well, we got this. 2. And for this y is 2. We're going to add 7 to the 1/2. Okay, then we got 1 over pi times negative cosine of pi over 2 times my x, which is 1, minus c. All right, we got this. We got this. We're good. Well, I put minus c. It's plus c. Let's put plus c. All right, because even if c is negative, I can add a negative c value. Okay. Here we go. 2 plus 7 is 9. 1/2 is like saying square root. The square root of 9 is 3. And 3 times 2 is 6 on the left side. All right. Well, this is nice because the cosine, we got pi over 2 times 1, which is just pi over 2. And the cosine of pi over 2 is 0 times 1 over pi, which is still 0. And then we just have our c on the side. Oh, that worked out really nice. Okay, this ended up being 0. Anything times 0 is 0. So 0 plus c. So c is 6. All right. So let's go back. Okay, now we're going to put our c in. We're going to go back right here at this point that I've written red, our equation with a c in it. And I'm going to put a 6 in for that c. So let's rewrite this. We have 2 times y plus 7 to the 1/2 equals 1 over pi times negative cosine of pi over 2x plus 6. All right, the first thing we need to do, okay, now we're going to get y alone. They want us an equation for y here. First thing we're going to do, we're going to divide both sides by 2. And don't reinvent the wheel, okay? Oh, well, that's weird. Don't reinvent the wheel. So I've got, I'll do this down here, y plus 7 equals, I'm going to put this all over 2. I'm not going to try and simplify anything crazy because that's when people make mistakes. It's all over 2. Okay? Now I need to subtract. So, oh, that's to the 1/2 power. Oof. That'll change our answer if I don't write that. So now I want to square both sides. Okay? If I square the left side, it gets rid of my 1/2. But then I got to square the entire right side. Man, there's just a lot of writing here. So I have y plus 7 equals 1 over pi times negative cosine. I could put a negative in front of the 1 over pi. I'm just writing everything the way it is. 2x plus 6 all over 2. This whole side is squared now. And there's one final step we need. We got to subtract 7 from both sides. I mean, I suppose I can write it, but nah, I will. Y equals 1 over pi times negative cosine of pi over 2 times x plus 6. This whole thing is over 2. I'm squaring it, then I'm subtracting 7, and we are done. That was a lot of writing. 5A, 5B, and 5C were pretty simple. So I knew 5D was going to be some sort of work here. All right? And that was a lot of work. I ain't going to front, I ain't going to lie. Okay, so, I mean, we had to get the dy and y's alone, the dx's and x's alone. We had to integrate both sides. We actually used u sub. Okay, we came up with an equation that had a c in it. We solved for that c and got 6. Put the 6 in for c on the right side in blue, and then simplified. Just got the y alone. And when everything was all said and done, that's what we got. Wow. Thanks for hanging with me for that one. That was some work. That took some time. But guess what? We're done. You know, there are going to be problems like this on the test. It won't be laden and saturated with problems that are like this. But you will get 1 or 2 like this, maybe 3, okay? But for every one like this, there's going to be one that's a piece of cake, okay? Like 5A was. And really 5B was easy, and so was 5C. So there you go. There you have it. Free response question 5 is now in the books. We are done, and I will see you for free response question number 6. Bye-bye.
Don't forget to subscribe and ring that bell.